Internal to APPL, random variables need to be stored. The designers of APPL needed to decide on a data structure to hold a random variable. The decision was made that a list of lists in Maple would be the way to hold a random variable in APPL. So the first of the three lists contains the probability mass function or probability density function values. So if it is a discrete random variable x, you might actually list the mass function values right there, and you'll see that illustrated on the next example. If it is a continuous random variable, then you will actually put in the probability density function. The second list contains the support values. So for a discrete distribution, you might actually list those support values right there. For a continuous distribution, you will put the lower bound and the upper bound of the support, and those can be infinity and negative infinity if need be. If a distribution is defined in a piecewise fashion, where it has one particular functional form over one interval and then a different functional form over a different interval, then in that case you would put in the breakpoints onto this list as well. The third list contains two strings, and the first string will tell you what type of random variable it is. That is it a discrete or a continuous random variable? And these have to be in double quotes. And then there will be a comma, and then the second string will indicate the contents of this first list. So if it is little f of x, that is a probability mass function or a probability density function, we will always call that PDF. If it is a CDF, capital F of x, that's in there, it'll be CDF. If it is the inverse of the CDF, then the letters IDF for inverse distribution function will be in that string. And finally, if it is a survivor function, SF will be the string that is given in that particular field.